day to you. This is Anticonic bringing you another science presentation in spherical geometry. We are now fully prepared to make the jump to hyperspheric space. For you Star Wars fans, you can put away your toys. It's time to grow up. But I do want to remind you, as I've reminded myself, that this is the jump to warp speed. This is when all the stars just flash and suddenly you're able to travel through time to get to other places in the universe without any problem at all. That will never happen physically due to limitations that Einstein has pointed out. However, we can now do it in our minds, and this is the gift of geometry. The ability to visualize, perceptualize, and utilize the actual universe the way it actually is. As you know, it took a while for mankind to achieve a spherical geometry. That was accomplished in 2022. And now we're capable of using the spherical construction of space in order to extend it to space-time. That's what we're going to do now. Upon doing so, we will find ourselves in a position to extend spheric space, which is then space-time. We'll be able to extend that to hyperspheric space, completing all of the paradoxes and solving them so that we actually know what the universe is. That's the lab cat. She's going up to her perch. We left off in the last lecture with two surfaces to the spherical universe, which have two different perceptual characteristics. The inner surface of spherical space is called the infinitesimal, and the outer surface is the integral. These imply actual numbers, and indeed they are actual numbers. However, they involve something that we already know about from mathematics and geometry, something called imaginary space. It has been utilized successfully in a couple of contexts, but this is the origin from which our linear notion of complex or imaginary space is derived. This is the actual imaginary universe. What is the real part? The real part is so far what we've constructed to be space, which now has an index and a metric. So if you don't understand what I just said, just review the last lecture prior to this one and you'll know. However, if you do understand those terms, we're ready to proceed. We have a static spherical universe. This would be the geometric construction of the universe as we actually perceive it, which is spherical, of course. The numbers that fill space are whole counting numbers. The actual numbers that will comprise that space depend on a reciprocal relationship between the highest number and lowest number. But we do know what the index will be. Whatever the actual spheric distance is for the quantum jump from 1 to 2, that distance can be decreased to any actual physical distance, just short of no jump at all. If there were no jump at all, there would be no space. So there is a jump, and that's unavoidable. That is called the quantum jump. That now needs to be distinguished from what physics currently understands to be the quantum jump, which is erroneous because it's a derivative solution in linear space. This is what Max Planck discovered about energy transfer, and it is also what Albert Einstein discovered about the transfer of energy in light form. These must be continuous processes. That has been known for 250 years, and now it's necessary to realize that continuity is the definition for the mechanics of space. That is, the mechanics of space-time. So, Currently we have space, which is completely filled with numbers and therefore subsumes the linear concept of numeric distance, which is a linear concept. Obviously, it is constrained to the line. We've transferred that now to a spherical concept of distance, which involves a mind stretch, since we don't see in all directions at once, but the universe operates in all directions at once, in the two forms of force that we find in the universe that are, in fact, either inverse or reciprocal. We'll be getting to that. But this would be centripetal force, which we call gravity, and centrifugal force, which we call light. So those are the two forces that are completely in balance and 100% define the universe. That is one of the answers that physics has been seeking, and so we've solved that. Now we need to prove it to show that it's consistent and useful. We have not yet involved time. So now we want to find out where time enters into this construction. We know that the sphere is the proton. That may seem incomplete, but accept it for now because we're only dealing with space, and as I've rigorously proved, the proton is the spatial infinitesimal. It is the spatial particle. It's the spatial impenetrable core, which has a surface value of 1 in the spheric number system. Technically, 1 in proportion to 1. What are these numbers that are in proportion? Well, they're both unity. So now we're going to make a hyper jump based on what physics has already discovered about light speed. You know that light speed is by far the most amazing number that has ever been uncovered by physics. It is the only constant number. It is the only number for which we have an exact value. It is a two-component number. Light speed is conceived as distance over time. Obviously, that would be space over time. That is the construction that Einstein used to orthogonalize time with space. This would be time with cubic space. We now are capable of making a direct relationship between space and time in a two-component number system. Currently, we find that the whole numbers comprising space, which would be 2 over 1 for the quantum jump, and then the successive jumps we can conceive of as harmonic jumps for now, because the concept of linear separation is limited to our system, which would go 1, 2, 3, 4, 5. In this case, we want to be sure that we're in consonance with the actual numeric system that the universe uses, and therefore we're going to assume that the metric is harmonic, which means that the first jump is from 1 to 2, and the next jump is the first jump is from 1 to 2, and think of that as from 1 to 2 to the first power. And the second jump is from 2, which is 2 to the first power, to 2 to the second power, which is 4. This is called a harmonic sequence, and we will be able to fine-tune that when we understand the relationship between space and time. Currently, we have made the quantum jump without defining what that actual distance would be in physical space, the way we would measure it on a straight line. What is the separation between the inner sphere, which is 1 over 1, and the next sphere, the quantum jump? Using the index, that would be 2 over 1, which would have a surface value of 2. You could actually draw that with a compass and ruler construction, and then find out the exact linear separation between those two surfaces. But for now, we're only interested in the fact that we can fill space with numbers to an arbitrary degree. we've covered that in the previous lections. So, I don't want to say lecture, presentation. And and so now we're going to capitalize on what we know from physics currently. Even though it's linear, we do have an absolute, which is really saying something just using linear numbers. But actually, light speed is not a linear number. It's composed of two linear numbers, one of which represents spatial separation, and the other one is time, which would be time separation. We're going to unitize that in order to extrapolate hypothetically on what our number system implies for geometric and physical space by saying that the surface of the proton, we're calling it the proton for now. It does make logical sense. Since the proton is the space particle, it forms a center to space, and no other particle does that. And so it can be said that the proton is the only particle if you're only talking about space, and that has been proved by science. It has been proved in the Hadron Collider tests. There's nothing smaller than the proton, and it can be said honestly that there is no physical interior to the proton. When it's blasted apart, it produces shards, which the mathematicians have been frantically trying to correlate, and so far with practically zero success. However, certain inevitable relationships have been found between these sub-subatomic, they're sub-sub particles. And they're not actually particles, but we have to call them that because they seem to be particles. They leave traces in a bubble chamber. Whatever those things actually are, they have mathematical relationships which can be established. There's something called the eightfold path, another grandiose, megalomaniac term used by the insane particle physicists who are under the control of the government, of course. So they're artificially excited about things that will never amount to anything, and so far nothing has amounted to anything from the collision experiments, except we found this eightfold symmetry, which has been perceived by the mathematicians without effect. They have no idea what it means, but they love to glorify themselves in order to make money. A second discovery was made about the proton, which was the only real result of these experiments, was divined by some genius named Gell-Mann, and his name is spelled, he spells it in a very strange manner, and I tried to check why. It's Gell-Mann. Well, you're allowed to name yourself whatever you want, but it's Gell-Mann. So Gell-Mann discovered a mathematical definition of the constituent parts of a proton, which would imply that it has something inside. But whatever is inside the proton cannot be isolated, and that is now known. That's a fact. That is fully admitted, although not very loudly. What's really loudly acclaimed is something like the Higgs boson, which is perfectly meaningless, except to the mathematicians who are making money off of these chimeras. But this is a valid discovery because it involves the number 3. And the number 3 is something that has quite a mysterious quality in the number system we have come to realize works for us on Earth. The 3-quark system. Now we're going to approach that, but not in this lecture and not soon. However, it can be stated accurately that that 3-part system, which is the definition of the proton in some sense, exists in imaginary space. So this is a major breakthrough. It may be the very first breakthrough to the physics of hyperspheric space. It will never be understood as such because physics doesn't have hyperspheric space, and never will, because it will never listen to me, for one thing. But if it could know all that I know right now, physics would realize that if you have a spherical system composed the way you and I just composed it, then you can now realize that the three-quark system, which constitutes the proton, dynamic. It's the dynamic quality of the proton. This would be the system of three quarks, which defines how space is curved by the proton. That will never be understood, but you and I will understand it, but not right now. First of all, we have to make sure, using the rigorous process of scientific proof, that we take this step by step. Now, what we do know is that light speed is constant. There's often a footnote given to that it's the speed of light in a vacuum, which has since been changed, since the concept of vacuum is not exactly right according to physicists. But whatever space is that light travels through, when it travels through empty space, it travels at exactly a certain number. And this is a whole number, which is remarkable. There are very few whole numbers in physics. Virtually everything, if not everything, in physics is irrational because we're using linear numbers which do not correspond to curvature at all. Well, with a caveat having to do with calculus and a lot of other things, but you and I now have the actual geometry with the actual numbers that the actual universe actually uses. So that one that constitutes the surface value of the proton is light speed. That is light speed. And we're going to prove that now using a very simple construction due to the fact that we have spherical space to work in, which physicists do not have. They don't have a portrait of reality on any of their blackboards or in their heads. So that explains a lot. I hope that comforts you when you notice that it seems like the particle physicists are psychotic. They are. They're just as psychotic as the cosmologists who say that the universe is expanding. We're now going to fix that so we can perceive everything the way the universe tells us. What the universe says, not what the universities say. What the universe says. You can take your choice. The universe won't pay you in money. But for a wise man, there's no contest. We want to know what the universe says. And we leave everyone else to their own devices. Excuse me, I don't know how I left this in, I too. Oh, little goody. Well, sorry about that. So, light speed is 1. And therefore the 1 over 1, which is the two-component number for the surface of the proton, consists of 1 part space and 1 part time. We're going to call it time for now. Time is a very strange concept to put in juxtaposition with space. And we'll come to find out that it's not exactly time, but inevitably it is time. And there's a relationship between time and what actually is occurring on the surface of the sphere. So we begin by rotating the sphere. There is no sphere in the universe that is not rotating. The word rotation has several connotations which are inadequate, and so we wish to use the precision scientific term for what constitutes the motion of a sphere in place. This is not spatial. Space only exists past the surface of the sphere. The surface of the sphere is the union. It's the union surface of space and time. We're going to continue to call it time, but now we want to make sure we know what it is that's on the surface of the sphere that's physical, that differs from space. And that has a specific name. It's called angular momentum. Angular momentum is the common divisor for both space and time, is angular momentum. The reason for that is anything that can be considered to be moving in space is not on the surface of the sphere. It's off the surface of the sphere because that's where space is. The surface of the sphere is the union of space with the other component. And that component would be the 1/2, which comprises the other componency of the space component, which is 2/1, the quantum jump from the surface of light speed into space. That jump has a counter jump on the sphere, and that counter jump corresponding to a space shell is the rotational component of the sphere. It's the angular momentum component on the sphere. It's not in space. It's in something else. And that something else is space-time. So the surface of the sphere represents space-time. So far, this is not a match on what we know from physics, but we must find out if we can visualize it so. If we consider that the sphere has an angular momentum component, then what would be the index for that motion? Motion is a much better term than time. Motion we think of as something moving through space. That's motion to us. On the surface of the sphere, though, we decompose space-time into its time component. Now, the way this is currently done in the linear space-time formulation, the surface where time and space are equal, and that it becomes one, that the space-time component is one, that is called a cone. It's a light cone. And you've heard about the light cone. It is worshipped, just as the golden calf was worshipped. We're now going to melt it down in order to make actual currency for the universe, because the universe does not use a cone. The reason why the speed of light is represented in space-time diagrams as a cone is because it's projected down from 4D, such that if you begin at the center, called the vertex of the cone, that in linear space would be conceived as 0. That would be 0 motion through space-time. And that is the frame of reference. It's an arbitrary frame of reference for a volume space in terms of gravity, which is its magic. So this cone is actually a sphere. The way to visualize that is as a series of slices. As the cone goes out, it is an expanding circle, and it goes forward in time. You can disregard what is beneath, which is the negative quality, the reflective quality of time-space, is considered to be the past. You can disregard that entirely. The upper part is a single cone going up on the time axis, and space is considered to be infinite on the horizontal axis, because space must be considered infinite if it's going to be considered at all. The horizontal axis is all of space, and the point where the cone begins is the frame of reference in space. Horizontally, you're at a sphere that has no radius. And that would be you, or whatever your instrument is, or whatever you're conceiving as the beginning point for space-time. It is 0, both in space and in time. So that is the center of space and the center of time. Time has a gradient. We have a difficult lexical problem in talking about the speed of time. But one thing we do know about the speed of time is that we can at least consider it to be constant from a certain frame of reference, which is the light cone. The constancy of the speed of time is the constancy of the expansion of the cone through time. The expansion of the cone is the expansion of space. It's the spatial component of the light vector in time. Where that is 1 is on the cone. That is where time is going at the same speed as space is expanding. If that doesn't make sense to you, it probably should not, but this is very difficult to put into words, because this is an inversion on our concept of time and space. This is an inside-out sphere, because that cone, as it propagates, looks like it's making a circle expand, but that's because of the projection downward from 4D. And so what's actually happening is that circle is a sphere. And so you're seeing the propagation of the equator of a sphere. What is happening is you're following the path of a photon. And the photon expands as a sphere. And the surface of that sphere is the cone. I hope that makes sense. It's extremely difficult to talk about because this is inside out. But actually, that cone is an expanding sphere whose surface, this would be the surface of the sphere, is the surface of the photon. That would be if the frame of reference is talking about a single photon expanding from, we could not say what, because a lot is being left out. This is a very, very primitive diagram. It appears overwhelming, and therefore you might also be tempted to worship it. John Archibald Wheeler has no problem falling down, just pulling down his pants or whatever he does. He wrote a 150-page poem to this light cone, which I just find remarkable in the human sense that a man could degrade himself so severely as to praise this monstrosity. It's a useful monstrosity, though. It does enable spaceflight. This is the visual representation of the formulation of space-time such that it's possible to navigate inside the solar system. As for its usefulness in computing quantum mechanics or cosmology, we're trying to fix that now, so let's see what we can do with the actual diagram. So instead of there being a cone, what you and I are looking at is an actual sphere. This would be the actual universe, which has a center in a frame of reference. Now it turns out that that frame of reference is a proton. So accepting that, we now have the definition of the physical spatial universe that's with no motion. It's just a proton sitting there that generates a space. And the proton actually does that. It does it somehow with the 3-quark system, which you and I are going to unlock that secret once we're able to get to it. But I hope you feel a little bit of excitement if you trust this at all. You're not trusting me. You're trusting what the universe says. I'm merely telling you what the universe says. That's always dangerous. And I won't say any more about that. So now we have the surface of a single proton whose surface value is light speed. What does that mean? It's the same thing as that cone. It's the vertex of the cone. It's where everything meets. Space and time do not meet except at that point. But it's not a point. It's a proton. The proton is where space and time meet. So what would be inside the proton, visualizing the proton as an ordinary sphere, what would be inside the proton would be perhaps the time domain. We could just call it anti-space. But here we summon to the front of the court Albert Einstein, who gave us one of the most amazing insights into geometry, I believe, that's ever been formulated. It's just unfortunate that he only had stone knives and bearskins to work with, and yet he did it anyway. The most complicated, the most amazing formula ever devised by the mind of man, I believe. And we want the geometry that he was able to incorporate, which makes this work. It's only the geometry that makes this valuable. So what is that geometry? What was his insight that transcended anything that went before him? He was able to perceive and then prove that his perception was correct, that you can conceive of time as being orthogonal with space. That is, it's perpendicular. That needs to be explained, and that cannot be explained in linear geometry. It is literally impossible. But if you force it, you get that light cone. If you transfer to the correct geometry, you can see it. And that's what we're looking at. The sphere has an angular component. That angle, which we call angular momentum, that angle, which is a closed line, right? That's the motion. It's the repetitive motion, which we call rotation. It keeps coming back, doesn't it? Back and back to the same point. Click, 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 click. The only way to measure that is in time. Space is not measured in time the way we've constructed it. It's measured in shells that go out from the center, which is a spherical surface with a value of 1/1. The whole component, which is the one on top in the division operation called a fraction, if it's 2/1, the 2 goes out. In the other component, which is 1/2, the 2 we would think of as going in, and we've already discussed that in context of Zeno's paradox. However, Albert shows us That's a right angle. We can now see that's a right angle in spherical space, and that makes absolute sense. Because if you consider the force which would be responsible for the expansion of space, that would be a linear line, a linear ray that goes in all directions at once with a force value. For gravity, that would be in the reverse spherical direction. That the force line of gravity is what I call the radial line, which is all of the rays. In spherical space, there is no such thing as a line. Instead, it's a ray. Because it has a center, the spherical system has a center, and therefore there would be two forces describing the linearity of the spherical system. The linearity is spherical linearity, which has two force directions. Going in is on a line, which you can see it's not a single line, it's all the lines. There is a componentization of that linearity, which is either force going out spherically or force going in spherically. That would be gravity and light. Light goes out spherically, gravity goes in spherically. Everyone knows that. But what is not known until now is that the relationship between space, which you can think of as being contracted, it reaches a limit at the surface of the proton, where space stops. There is nowhere to go to get to the geometric center of that sphere. The sphere itself is the surface of space. So what happens when space is being pulled in by the proton? When space is being pulled in by the proton and space reaches the surface of the proton, it transitions to angular momentum. Instead of going in, it continues to go in, but not inside. It goes in and in and in until it reaches the one, which is the surface, and it transitions at a right angle to the radial line and becomes angular momentum. So the force, which is what we call gravity, when it reaches its center of gravity spatially, transitions to the angular momentum domain, which is the surface of that sphere. Now, because this is a angular direction, we're now talking about periodicity. The periodicity of space is in the shell system. It's purely spatial. So it's not really motion, which is why gravity has been often represented, and still is, as a pseudo-force, because there's no motion involved. How can you have a force without a motion? This is why. It is a motion. It's the motion of the contraction of space, which has a limit. And when the space contraction, as a force, this is a force line. So the line, this is no longer the shell. It's a force line that affects the shells. So the shells you can think of, if something were moving, then the shells are contracting. Or you can think of, for instance, an electron heading toward the proton, which it does. When it reaches the proton, it does not collide with it. It goes sideways. It goes orthogonally to its radial course. it's on one of those lines of the radial line. That's its linear trajectory through spherical space. So when it reaches the spherical center on its linear trajectory, it assumes the Boschkovich curve, and it curves at a right angle and occupies the shell. And that is the force surface of the proton. I hope that makes sense. That's 40 minutes. We are now prepared to jump to hyperspace. I make no apologies, although virtually I am making an apology on behalf of the universe, I suppose, or science, or limitations of human language. I keep saying that we're right on the verge of hyperspace, but I think you can see that this is kind of like the electron approaching the proton, where essentially we're changing direction on a curve in order to adjust our perceptual space to a geometry which does require a certain mind stretch. But it's the orthogonality that will save us. That is how we're going to be able to conceptualize space-time in order to have a motive universe, a universe with motion in it. We'll have another lecture today. I need to get something to eat. Thank you for tuning in. We are now ready. And in the next lecture, we will jump to hyperspace. All right, and you know what I always say at the end when I remember, keep looking up. That's where you're going to see everything that we're talking about. This is a direct translation of what the universe tells us so that we can lock our minds to the rational part of the universe and so be saved. And saved from what into what? That will be the subject of your personal religion, which you will never be able to share. This is the way to share religion. We'll be right back. This is Antigalactic.